Hello, I'm Michael Lyle, Tidewater Community College Geophysical Sciences Department, and this is the Lens Familiarization Cruise Briefing aboard the RV Matthew F. Maury. The project objectives, which you'll be doing, to utilize sampling techniques for waterborne studies, determine geological, chemical, biologic, and physical parameters at work at Rudee Inlet and Owls Creek. We're going out on land versus water. Consider that on land we have visible reference points and markers. Site survey is less difficult, access by foot and vehicle, and of course greater controls on precision sampling. On the water, you have little or no visible reference points and markers. Bottom surveys are more difficult. Access by boat, fewer controls on precision sampling, and provides an added dimension for earth science studies. Water bodies for study. We have estuaries, lagoons, lakes, ponds, streams, rivers. All of these, of course, are available here in Virginia, depending on what you're close to. Here's an example of a retention pond. This is fairly common in a lot of areas, especially schoolyards, shopping malls, places like that. And when you're underwater, of course, everything looks different. So let's talk about how you might sample this. You can do this vertically, and you can take either point samples at various depths, or you can do it at continuous sampling, depending on how you want to set it up. And then we have horizontal sampling over distance. If your means of getting on the water is by boat, we have small boats, large boats. Or if you're going to wade out in the water, as these folks are doing, then this also provides opportunities to see what's out there. Now, preparation for the water phase of the Rudee Inlet Owl Creek project. What to bring? Pencils and pens, recording information. We encourage people to use field notebooks consisting of clipboards, rubber bands, plastic rulers. All this is maintain good note keeping out there. Appropriate clothing. You can expect to get dirty. Dress warm, cool, or dry, depending on the weather. At least 3 hours on the boat. Dress so you'll be comfortable for that time. Footwear. The deck is metal and can be slippery. You should wear old but comfortable rubber-soled shoes that'll keep you from slipping. You can wear sneakers. They tend to get uncomfortable when they're wet. But please remember, open-toed shoes, flip-flops, sandals, etc. are not permitted on board. Food and water is necessary. Proper hydration is important. Ensure you start hydrating several days before the cruise event. If you feel thirsty, it's probably already too late for hydration. Seasickness. If you're prone to get seasick on the water, perhaps your family physician can prescribe a motion sickness tablet. Avoid alcohol consumption the night before your cruise. Get a good night's sleep so you'll be rested. Medical issues. Allergies, expecting prior heat, cold casualties, mobility requirements, etc. can all impact your cruise. Notify me well in advance of the cruise event in order for any special accommodations. Cameras, they're encouraged to get some good photographs. Please remember there's an interesting interaction between anything electronic and salt water. That includes cell phones also. If you're going to take photographs, put an object such as a distance measuring device, lens cap, and the picture for scale. Be sure to write down the number of each photo and a brief description of the subject to your notebook so you'll know what they mean when you upload them. Timekeeping device. A lot of sampling events require denoting time, so you will need a watch. Again, some people use cell phones, but there is that interaction with salt water. And we've had a few cell phones fall into the water also. Now, some background. Research vessels, they're designated to conduct oceanographic work for research and education. They come in all sizes and types, and are designed for specific or multi-use operations. The crew varies from few to many. On most vessels, crew are divided into two distinct sets of duties. We have the ship crew, operation, navigation, safety, engineering, communications, and medical, and the science crew, science, sampling, equipment, and analysis. Our study area, you'll see here, involves Rudee Inlet, Owl Creek. At some point, you're going to be probably moving throughout most of the Rudee Inlet area, and we're going to try to get you all out into the water right offshore here. Here is the RV Matthew F. Maury at Owls Creek. Here's a view from the starboard side. Get some idea of the deck layout in the back. Here's another view. You'll see the mast and boom on the stern deck. Some specs: length 50 feet, beam 13 feet, range 500 miles, 25 knot speed. We have some pretty impressive engines, and we can carry up to 15 science crew. Another view of the deck. You'll notice the gear out here, and there's some hatches, hose covers, other things here. So a lot of things to trip on. This is why we want you wearing rubber-soled shoes so you're not slippery. Off into the water. Another view of the deck. This is our GPS receiver, one of our navigation aids. So for much of what you're going to be acquiring for data, you'll see the position here. This is up in the pilot house. We record the latitude and longitude in degrees, minutes, and decimal minutes. Here's our through-hull side scan sonar. This is also up in the pilot house. It's available to you if you want to use it. And also we have a depth finder. Wind vane and anemometer. This is useful if you're trying to collect the weather information. Here's the wind vane and anemometer up on the mast. A little bit out of focus, but this shows the display box down in the cabin. Compass. We use this primarily for determining wind direction. On-station sampling equipment. This is a bottom grab ponar. The variations to the design are a little bit different here and there. Consists of a shackle point. You'll see that in the upper part. Safety pin, weights, clamshell halves, and this of course is designed to collect bottom sediment. You will not be using this, my crew will, but in any case, this is what it looks like when we have it. This is the ponar suspended from the cable line here, and one of my crew has got it already prepped and ready to go into water. Comes back out of the water. That's what it looks like. And you may hear the engine noise in the back. If you notice, they're playing all this out by hand. At the time this video was shot, the winch motor had burned up, and when we're out there on the water, we have to improvise quite a bit. It's coming back up. They'll hoist it up on deck, put this ponard in a tray, open it up. They'll insert the safety pin so they can use it without any injury. And then once it comes up out of the water, here you see it, another view of it going in the pan here, what it can look like. Now, once we get the sediment, you'll be free to do whatever you need to do with it. Here, one of our folks are using a Munsell color chart to get color to sediment. You can do this when it's wet like this, or you can do it when it's dry. I wonder if there's going to be a color change between wet and dry. We do have on board a microscope, and so here you can get a quick view of what it looks like. It's always good to do this before you get back in the lab. First impressions are always great working with sediments. Here's our NIO bottle, National Institute of Oceanography. Collects a water sample, about 1.3 liters in volume. NIO bottle here, bottle valves are closed. The bottle, when it goes in the water, we're going to have to basically trip it closed. So we'll show you how this works in a minute. But this is called a messenger. And we'll slide this down the line to get the bottle shut after we've got the water in those bottles. Here, bottles hanging on a cable. This is in the event we use multi bottles on the line and we need to trip one. So here he's pointing to where we're going to put another messenger to trip a lower bottle. And here we have a real quick video out on Lake Wesley from cohort 1 last summer, where they're actually using one bottle for this cast. The weight down at the bottom helps hold the bottle in the vertical as it goes in the water. There's Johnny, one of the crew. In the back there, putting a messenger on, is Billy Younger, our physics guru. Working the winch is Melanie Loney, science coordinator, Virginia Beach Schools. So they both have a second job in the event that they need some extra work. And so now they'll take the bottle off the line, pass it off to one of the science crew, and that's basically it for the NIO bottle. Another test that we can do on board is using our refractometer. And refractometers are very quick optical devices for measuring water salinity. You can express this as 0.00 or PPT. Both stand for parts per thousand. These are common units for water salinity. The refractometer, when you look through it, you'll see two fields, a blue field and a white field. The boundary between the two we can read off in specific gravity and salinity. Very fast, very easy to use. Here's our CTD profiler. These are very common electronic samplers. C, conductivity, T, temperature, D, depth. And here you see the CTD profiler hanging from the cable line. Additional sensors, we also have dissolved oxygen and turbidity on our particular model. Some information: our scan rate is 4 scans per second. Depth reading is 100 meters. Memory storage 256K. And then something we need to be concerned with is our surface equilibration time, which is 2 minutes. When we put the CTD into water, the manufacturer's recommendation is that the device be held right at the water surface for 2 minutes for equilibration of the dissolved oxygen sensor. So once we put that in, we're going to need to start timing it for 2 minutes, then we'll run it down to the bottom. Remember, when we switch it on, it's continuously running until we switch it off. CTD coming back up out of water here. Now, we also have a Secchi disc. You may be familiar with Secchi discs. They're fairly easy technology to work with, a lot cheaper than the CTDs, of course. And ours is measured in increments, meters and quarter meters, and a white plastic disc. This is one of our smaller models, and this is we use for ponds and lakes. They're fairly easy to acquire and actually fairly easy to make too. Here is a Secchi disc going into water, one of our larger ones, and we'll probably be using this on the cruise. Goes in, and we keep lowering it down until it just disappears from view. You'll see it here. And then we record the depth marking on the line. Here's a video of how that would look. Some of our oceanography students putting a Secchi disc into water. You can see it just reflecting off the surface of it. And of course, we want it to hang in the vertical if possible. If you have any significant current, it won't be hanging in the vertical. And then we just read that off. Tows. We've got a couple towing operations. And here's our towed side scan sonar unit here. Side scan sonar technology is pretty good. It allows us to image the bottom. And here you see a section of rocks over Chesapeake Bay Bridge Tunnel, first island. And some sound waves. This is just east of the bridge tunnel. We can also tow plankton nets, and these are used to collect samples of very tiny organisms. The plankton net consists of a very fine mesh netting, and in order to get the volume of water flowing through the net, we have what's called a flow meter. And you'll see from the picture here a numerical display, and there's a little propeller on the end of it. So as it goes into water, the propeller turns, moving the counter, and so we can take the flow meter in reading and the flow meter out reading, and then therefore calculate water volume passing through the net. Here we have the CTD correction. This is the plankton net, my bad, lowered into the water. And depending on the weight and boat speed, determine the depth of the tow. Here's the plankton net back out of the water again. That dark stuff there is, of course, plankton, very concentrated. Generally, we tow for about 5 minutes. The net is washed down, and then we'll have opportunity to recover the plankton sample. The otter trawl is used to catch larger organisms consisting of a float, net, and boards. Here's a view. This is not ours, but it's another vessel of what it looks like. You'll see the boards here, the net in the back. When we get ready to bring the net up, this is pretty much of an all-hands operation. And here you see some members of Cohort 1 doing a line haul. They're real excited about this. And when finally we get the boards up, bringing up the net, float, and then depending on what we have, gets all kinds of fish here. So hopefully your catch will look somewhat as well, or maybe better. Sometimes we don't get anything. And then at the end of the voyage, we have opportunity for crew rest also. What are your questions? If not, well, then have a good day.